Okay, I'm now recording. So I'm going to start by showing you a couple of Linux distributions that are not part of the standard run-of-the-mill type of things, but they are very much used in industry. It's just that you don't hear about them much. And so what I'm going to do is start my screen share and go to the full second screen here. So this should get everything in that screen, including the base. All right, here we go. All right. Now you're saying, now why do I need to know this? And I said, well, this is a really good question. This is, why does my instructor talk about stuff that's not on the test? True, good argument. How about a job? How's that for a good argument? Okay, so what I'm going to do is pop over to this little distro. I might have brought it up very quickly. It's called tinycore Linux. It's a full Linux kernel that runs TTY only 32-bit and 11 megabytes. Now, that's basically the size of one small research paper you have to do for English. So it's really tiny. Where is it used? Amazon uses it for every single one of their scan guns. I had a student who was working for some wineries I don't know if he is a consultant or not, but he was working for wineries, and he was asking, the question came up saying, do you get no tinycore? Oh yeah, I learned it in school. My instructor played with it. And he said, and they were willing to offer him a job, but it was such a cut and pay, he didn't want to do it, which was legit because, you know, you don't want to change jobs, work harder and get less money. I'm sure those days have changed in the days of the Great Resignation. So tinycore Linux is something you need to investigate on your own in your free time. I had one student, well, more than one student, take tinycore and put it on their Raspberry Pi. Now, if you do that, I will guarantee you, you're going to learn a lot because there's no bootloader for tinycore. And that's one of the things I'm going to touch base on today is bootloaders. And you've had some sections on grub, and there are many different bootloaders for the world of Linux, okay, as with everything in open source. All right, so that's tinycore. That's a neat little one to play with. I use it to set up, I've been using it to upgrade the machines in the lab because it boots so darn fast. And I have a custom distro that I built. And so it's got the tools I need for forensics. You can also boot Kali Linux, okay? And that one I highly recommend if you have anything to do with networking or security. You're going to have to know Kali Linux because it's built on a Debian platform. They're using the XFCE windowing manager. But the nice thing about Kali is you don't have to spend 3 hours configuring all the tools. You boot the thing as a live CD or a live ISO off a USB drive, and boom, all these really fancy tools like Wireshark and all the rest of them are already configured, ready to rock and roll. That saves you a ton of time, okay? So Kali, there's other ones out there in that space for security, and Kali is used for both Red Hat and Blue Hat. Blue defends, red is penetration testing. So it's used for a lot of those things. And Kali makes their money by selling courses. And the way it's called offensive security. So if you go to offensive security, you can see the classes that they offer, and they use the Kali Linux distro in all their classes. And my recommendation is you put it in a virtual machine. You probably don't want to run Kali as your primary box running off disk because there's so many security tools, they can be turned around against you. So run it in a VM or run it as live because that's what it's for. It's designed to penetrate other systems. So if you leave penetration tools on your server, you're leaving yourself open to somebody's going to use those tools once they get in against you. Okay, so just a word of warning. Okay, the other little distro that I've been playing with, I've been having fun with, I actually spun one up on Linode or Linode. It's called Alpine Linux. And it's not what I would call way outside the norm, but it's outside the norm enough that you kind of need to know why it's so different from Red Hat or even Kali when it's installed on disk, Debian, or what have you. Okay, the Alpine Linux. Now, this is where I'm going to go back to. I'll zoom in on the whiteboard and go back to a whiteboard screen share here, and let me turn off my screen share. Where should I do it? No, I'll do it on the screen share. Where's my? There it is. Come on. Don't you love this stuff? Isn't technology grand, except when it doesn't work? There it is. Okay, so now you see my clock with 4 red dots. I'm going to move the clock over. And this is also for tinycore, okay? Tinycore and Alpine. And there's a few others like Puppy Linux, and there's a few others. But Linux is still Linux. Linux still has this thing called the kernel. And I mentioned previously that different companies like Red Hat and Debian have different package managers of the way you add what we call user mode to the Linux subsystem. Well, Alpine Linux and tinycore use something called BusyBox. And the way this works is BusyBox is one tool with many tools in it. So if you do a Google search on what is BusyBox for Linux, you find 30 or 40 tools that are bundled into a single executable that runs on Linux. So when you think about this, you have your most common tools. You're going to have your shell, you're going to have grep, and all these other neat tools you use at the command line. Well, in a standard distribution like Red Hat, SUSE, Debian, each one of those is a compiled module or a compiled runtime that sits on your disk that gets loaded and then unloaded and so on and so forth. BusyBox has all of those compiled into one executable. And then you say, why don't we use BusyBox? Well, you can for most things, but there are times where you just need a real command line with all the tools. BusyBox is also much, much, much smaller, okay? And this is how you can get tinycore and Alpine to be so small. They don't have a big user mode because they expect you know what you're doing, okay? These are rammable. In other words, you can load them in RAM and remove the boot media and run the entire distro in RAM. It's a great way to learn how routers and stuff work, because that's basically what they do. Is you load it in RAM and you manipulate RAM, and then you have to commit changes to the RAM, or when you reboot, it's lost. Alpine does all that. It's called LBU, and it commits the writes to RAM, so the next time you reboot, it's there. Pretty clever. And then on the other side of the user mode, when your machine initializes, everything inside your world that you're learning and test out is either the Init RC or System D, okay? And System D is where everything's evolving. Back in the old days, when you had Init scripts, you had to be very careful how you built them based on what was loaded when. For example, you couldn't load the database before you could load the networking. And so you had to set up these dependencies to make sure things would work in the right order. And it got to be quite a bit of a headache. But then systemd came along, which everybody loved to hate. But the thing is, it solves a real problem, because as systems get more and more decoupled from the kernel, you can put them in systemd. Hey, I'm going to boot this time, but I don't really need everything booted every time. Okay. So systemd makes it very easy to turn on and turn off services that are available or not available after boot. However, in the world of Alpine Linux, that doesn't exist. There's no system, you can install it. You don't, and same with tinycore. They don't use them. Okay. tinycore uses what we call the old version of init scripts, which is init. And this is, they say, oh, it's history, I don't need to know it. Yes, you do, because systemd is nothing more than a wrapper around init scripts. And Alpine Linux goes back even further in time, and it uses what they call OpenRC, which comes from the BSD camp, and it allows you to initialize your system using very, very minimal tools. So between the two, tinycore is a little smaller, well, quite a bit smaller, but Alpine you can actually use as a server. Let's say you want to create a hardened mail server. Alpine Linux would be a great way to do it, because it'd be small, fast, low overhead. Let's say you wanted to create a, like what I'm doing online as an experiment. I'm using make docs and an Apache web server, and I'm going to put it on Alpine. I'm not even going to set it up to use SSH to access it. So I'm using one of the tools called Lish out of Linode that basically takes TTYS0 traffic, your COM port, and puts it onto the IP. So you can actually do serial console stuff over IP. That means no X, no GUI, and basically no mouth. So you have to know everything by the command line. And I'm doing this kind of an experiment for myself to kind of see how things work. I want to do some speed tests. So for me, it's more of a learning game, learning adventure, which I should probably put in a blog somewhere. But those are some basic small distributions. There's other ones out there. One is called Rancher. And from here, Rancher OS. And I'll go back to the screen share. And I want screen 2. Rancher. What's interesting about Rancher is it's kind of a hybrid. Okay, and it says no more actively involved. What happened? Oh no, Susie bottom. Okay, when you think of Rancher, think of it as the server you need to run a bunch of Docker containers. Okay, and SUSE has been kind of the winner in this competition, shall we say. How fast can you get an OpenShift cluster and put Kubernetes on it? SUSE is definitely the way to go that route, because it's just so much faster and easier and less cumbersome than the Red Hat. Red Hat gives you a lot of flexibility, but for 99, well, say 90% of your use cases, you don't need that much flexibility. You just want it to get it up and running. So SUSE bought Rancher to kind of fit that use case. Okay. And you can see what it requires in RAM, and so it's pretty low. And a lot of these things, like Rancher and Alpine, are actually slowly but surely evolving into the cloud base OS. Remember how we talked about the idea of a BIOS? You have a BIOS on your hardware, on your motherboard. And most of you don't even know what it is because it just works. Well, that's where the operating system is going. The operating system is going to be slowly migrated into the cloud. And then when you run your Office applications, it's going to be on an operating system in the cloud, and you only see the applications in the browser. All things that are old or new, this is the exact same way the mainframe worked. You had terminals that were dumb, literally dumb. They couldn't do anything except display screens and take a keyboard input. That's where things are evolving, where your browser is your terminal. And all the hardware around the terminal, i.e. your computer, just supports the browser, okay? That's your future. The better you understand how those layers work, the more job opportunities you're gonna have, because in the world of the future, it's just more and more things are gonna be moving into the cloud. Like right now, there's this big open source movement. Yay, raw, let's go for it. But in time, you will see companies buy out open source, and there will be less and less of it available. This has happened in the past. It's going to happen again, and then there will be a breakdown and then start all over again. It's just the way history works in the world of computing. It's very much a it's cyclical. What I see now is kind of like the early days of the PC, where everybody and his brother was getting into this cloud thing. There's so many tools and tool chains you can get. You can get lost just trying to follow it. Okay, but then it explains how it works, and so that's kind of another one. There's more out there. But the meat of what I want to talk about today is a little bit of, I'm going to give you a fun challenge here. This is not going to be a lab I require points for, but it's one of those things that you could put in your portfolio on how you created it. And this, you can find it. You can say, create a bootable Linux USB with multiple ISO. And you will probably end up with pen drive Linux. Yeah, this guy. They give you all these tools. There's Yummy. There's a bunch of tools that make this drop dead simple. My challenge to you is don't do that. Do it this way. Do it using grub 2. What this teaches you is how the ISOs are actually constructed and how an ISO actually boots. And then you set up the grub stanzas to actually boot the ISO. As you've probably played with your VM, all you need is a .iso to boot your VM, right? Well, this is kind of the game that this works with this particular pen drive Linux. Okay, and how do I do it? Well, you format it to a single partition, and then what you end up having to do is actually create a partition. Now, this is legacy boot. This is not using the new. This is old school booting. Okay, and then you have to basically make your pen drive bootable via grub. Okay, and see, they did include some instructions on how to do it. Okay, this is how you do it. Now, be very, very careful. I've had students trash my machines in the lab because they just followed the instructions and didn't think through anything, and they wiped out the drive. So I had to restore. But it was a good learning opportunity. Okay, and they're showing you how to do this. And let me do this, copy, and then I will put this into notes for today. So I will put this on the website as well. So we talked about tinycore, Alpine, Rancher, bought by SUSE. Okay, all right. And save the file, come back. All right. So it's basically walking you through this process, and it gives you these scripts on how to do it. But I want you to notice some of these things. It shows you tinycore, and then when you're all said and done, okay, this is it's downloading it. See, all it's doing is downloading the ISOs. But what are the versions? That's not too bad. Debian 10 is not too old. Ubuntu 21. So they've updated this quite a bit. Okay, so this might be helpful for you because it's actually modern enough, it's new enough that it's actually going to work. Okay. So now what happens is when you put your USB in and you boot from your USB, your grub entries will show up and said, do I want to boot tinycore? Do I want to boot, what do they have here? Debian, Mint, dban. I forget what dban's for. I think it's a recovery tool. Tinycore, and then the mem test. You can actually do the mem test, and that it just checks your memory on your machine before you try to boot anything. But going through this process of creating a bootable pen drive that has a bunch of ISOs that you can choose which to boot from teaches you about grub, okay? And grub is one of those tools that if you screw up, your machine doesn't boot. So I don't want to screw up my machine. Yeah, I don't blame you. So what you want to do is put it in an environment where you can get at it and play with it, okay? And this is actually a good way to do it without causing any dangerous problems, okay? Now, what I do want to show you is some of the grub stanzas that make grub so interesting, okay? I personally happen to like grub, but there are operating systems that don't use it. tinycore for one, okay? tinycore does not use grub. You can install it and set it up so it will, but by default, it uses something called syslinux. Now, let me go back to my turning off the screen here, and let's talk about a little bit of whiteboard history here. And let me make sure I get my things here. Let's go back to the days of the PC when you formatted your floppy drive. It was an A drive, and you wanted to make it bootable. You had to use the format command. Now, I'm going back way, 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 way back. Some of you won't even remember this. I'd say most of you. Format C drive, and then you would say, well, I would say A drive, make it reality here. A drive, and then you say /s, make it bootable, okay? And then there was a command that came with DOS all the way up to DOS 5, 6, what it was called sys, S-Y-S. And then you give it the name of the drive, and it would flag the drive as bootable, okay? And you could go on and you could boot the hard drive, okay? That was in the world of Windows. Now, in the early days of Linux, they only had one bootloader. It was called syslinux, okay? And it was basically did the same thing. Syslinux is really simple. You run syslinux against your target drive, boom, it's now bootable. That's it. No dual boot, nothing fancy. You just boot the OS. The next one that came on was Lilo, which stands for the Linux loader. This allowed you to do primitive dual boot if you really knew what you were doing. And it was not for the faint of heart. Lilo is still used in embedded systems because it's efficient and fast and it less overhead. You know, grub is yet another big object that needs to be compiled and run and loaded into RAM and blah, 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 okay? Then there was grub version 1. And what it did is this stands for the Grand Unified Bootloader. This was to solve the pain point of dual boot machines. Okay. And it worked very well. And now grub is up to version 2, and it has all kinds of wonderful features built into it. It gives you a ton of flexibility. For example, if you boot your machine and you loaded it entirely, and you're saying, oh, darn, this is a server. I don't need to boot X every time I'm running my web server. You can go into grub and say, turn all that off, which is kind of nice. You know, you can say, forget it. I don't want a GUI, even though it's loaded and I can start it later. Okay. All right. So those are some of the bootloaders that show up in the world of Linux that you can add to your trivia hopper. So when you continue to get jobs in this field, you'll kind of know what some of the history is here. But if you understand grub really well, that's probably 90% of what you're going to need for the job. Okay. Yeah. All right. All right. Yeah, grubs gives you a lot of flexibility. Okay. All right. What I'm going to do is, well, let's see, we talked about this. This one's the best, right? The red one. So what I'm going to do is look at my existing grub entry. And I'm going to talk a little bit about grub, okay? And change directory default, and whoops, change directory. you saw that? Etsy, default, and change directory to grub. And there's this config file. Whoops, this isn't it. Pardon me. Etsy boot grub. Okay. I'm just having a brain fade. It's a default grub. No, that's right. That was change Etsy default grub, not grub D, just grub. Cat grub. There we go. This has a lot of stanzas in it. Okay. And it starts, the ones that are most common are right here. Okay. The other ones are down for really strange things. Notice this. Uncomment to disable graphical terminal. Grub PC only. Grub terminal. What does that mean? What that means is when you've installed Linux on a computer and the mouse and the keyboard and the display are all connected to the computer, when you turn it on, it basically removes all X and it will be console only from that computer. Okay. Now, the other stanzas are here. Okay. Now, there is a lot to this. There is really actually quite a bit to this grub config. Okay. Now, what's this talking about? Now, what grub default 0 means is boot the latest kernel. Now, you can set this to boot not the latest kernel. You can say timeout hidden or not. How long is a timeout going to be? I like to put a timeout in here because sometimes I need to change the flags on grub. And then this is telling you what the distribution is. Now, little secret here. Look at this command, lsb release. I'm going to open another terminal and type in lsb release. If I can spell. Oh, have to be root. Bad type day. Oh, wait a minute. It's not found. What's going on here? But here it runs. And notice it's taking the output and putting it to dev null but saying, I'm running Debian, even though I'm on Ubuntu. Okay. Now, in your shell scripting, you have this funny backtick. Dragons. Dragons beware. That backtick, when you copy and paste across systems, may not come across as a backtick. It may come across merely as a single quote, which means it won't work. The modern way to, I'll go ahead and edit it because it won't let me change it because it's read only. The modern way to do this, and you will see both in print, okay? You'll see it this way. That is functionally equivalent. Basically what this is saying is run this command, and after you run it, return the results and display it, okay? So what this command is actually saying, run the LSB release command, take the error and run it to dev null, but take the standard in, which is number 1, okay, and display it to the screen, or simply echo Debian, okay? And then this command line says, what do you want it to see? This is the default quiet splash. That means it shows the screen. So you can change these to all sorts of things. In the early days, I would change it to text so I could actually see the screen roll by. But over time, I don't need to watch that every time I reboot, especially when you reboot 30 times in an hour trying to fix something. And this command line Linux here, this gives you some ability to do some really interesting things with your TTY. For an example, you can enable your serial port if you have a PC that has a serial port, so you can connect a dumb terminal to your serial port and actually manage your Unix box. Now, I usually do a demo of this, but I have not figured out an elegant way to show you how this works without having the hardware in front of you to explain it. It's all very abstract and nebulous right now. But what I'd like you to think of is if you could go back to the days of your great-grandparents, probably working on the mainframe, that when they turned on the monitor, they had a single connection to the mainframe. It was usually either TDI or serial, RS-422, whatever. And you would use this communication back and forth to display your screen, okay? Now, the closest I've come to be able to demo this is this, okay? I was looking at this last night and was trying to figure out how best to show it to you. So what I'm going to do is pop into my server box here. And let's see here. I want to go, well, my new toys, I should say. Okay, that's not it. I want to go all the way up to, did I put it in here? Nope. So it's not in there. All right, we'll do it this way then. What I'm going to do is log into my Linode account. You can see my Linodes. And you can get all kinds of cool stuff. You sign up. They have their nanode. And yeah, right. They don't do clear text passwords anymore. All right. So if I click on this one, the Alpine, notice I have some access here, this Lish console. I'm going to copy this. And I'll go back to this red terminal. Now, what am I doing here? I'm using SSH minus T, which is a specialized flag. You do man SSH and find out. It's taking me to my Linode account, which is actually in Fremont, and telling me which of my Linodes I'm going to boot. And I hit enter, and then say yes to all these questions. Now I use a different password. And once it comes up, whoops, I didn't type it in right. Let me try that again. Oh, it did come. Did it? Yes, it did. All right. Notice this is my login prompt now. This is the actual login. Okay. Yeah, I didn't import the keys because at the time this is a play box. I haven't got SSH set up on this, and right now this is the only way to get to it is through the Lish. There's no SSH on it, I think. No, I want you to notice this right here. So let's keep the topic to what you're supposed to be learning, okay? So the topic is serial port. I am connected to a serial port on a machine in Fremont over TCP/IP. Now, most computer rooms have this set up this way, where you have what they call a keyboard switch that uses IP to connect to the serial console. In the old days, you didn't have a choice. You actually had to walk into the computer room, go to the serial console, type stuff in, make it do its thing, get the networking to work so you could do remote admin. The switches that you need to be able to do that in a computer room are freaking expensive. I don't have enough money to buy one of those, okay? Are you saying we'll need serial access to it? It says it's not allowed because they never crash. It's not allowed to you, but you can bet their senior admins have serial access to their domain controllers running Zen, okay? You can bet that. You won't. You're a standard user. They're not going to give you anything. Linode gives you everything to do whatever you kind of want to do. So I can log in now, do my thing, but this is what I want you to see. This is kind of cool. I'm going to reboot. I'm on a serial port. What are you watching? You are watching the same stuff as when your machine boots, okay? All right. So it's actually going to reboot now. And then when it comes back, you're going to see the same stuff that you see scrolling through your console. You can see where the use case would be for recovery. Your machine gets corrupted somehow and you can't get to networking, you can't figure it out, but you've got the technology set up so you can reroute through the serial port, because you can now control multi-user to single user. I can actually boot this machine into single user mode, disable everything, and be able to manage the box, okay? All right. This does take quite a while to boot, so that's just the way it is. All right. So what you'll see is that once it decides to come back up, you'll see the serial ports screaming through, okay? All right. I have a warning. If you best practice for recovery and copy and paste. If you copy and paste and you don't know what it's supposed to do, don't do it. You can trash a lot. Just like when you see a QR code on a telephone pole, never scan it. Okay. So what did you just see here? It was actually scrolling by. Now this is all pure. I'm using, that's the funny up down arrow. That's what happens when I try to scroll. What's going on here? Why is this so messy? Well, this is TTY traffic, no GUI here, okay? So I'm actually running, I don't know, whatever the baud rate is, it's communicating, okay? All right, so to put in, well, first of all, you have to have the TTY set up on your Linux box to be able to actually use it. And when I have the classes in class, we actually wire up a couple, and it actually will show you how it works, okay? But that's one of those things that's kind of hard to do remotely because I have no way of giving you the equipment. I use a Raspberry Pi PC. I boot the Raspberry, and then I get a serial port to DB9, and then we connect it to one of the servers in the rack in the back room, okay? But you don't have all that stuff laying around at home, okay? So, and even if I showed you a video, it's one of those things that would never make sense until you were pushed against the wall and you actually had to fix something. And then you're going, oh no, how do I do this? Well, that's when you're going to go call tech support, and they're going to walk you through the process and so on and so forth. It's nice to know this stuff ahead of time, but it's not very often you need to jack into a machine through serial port to fix it. Unless you do something silly like I did. You set the firewall up and you close yourself off from getting in. You're not nuts. So you go in through, in my case, the Lish on Linode, and I sat there and fixed my firewall saying, oh, okay, now it's gonna work. So that's what happens when you get rushed. You make silly mistakes, okay? All right, so those are some things that's the bootloader from a slightly bigger picture. Now, if you make any change to your bootloader at any level, you have to run something called update grub on Debian or Ubuntu. Does anybody know what it is for Red Hat or SUSE? Put it in the chat window. I'm curious. Yeah, because this means, you know, there's the whole section on boot and grub in chapter 4. So this is giving me a rough outline that either you don't remember what you read, or you just remembered it long enough to pass the quiz, okay? Now, I will say, if that's your approach to learning Linux, it's fine. You can do that. You'll pass this class just fine. But it's going to be very difficult for you to get a job because you won't remember anything from the interview. Okay, so that's your call, you know. So in Red Hat, it's called grub update or make grub, or there's variations on a theme. But basically what you're doing with this is that when you run this, now I can run it because there's nothing going on this box. Update grub. And then you put in the password. And what it does is it goes through, and notice what it does. It sources this file. That's the file we just looked at. It brings it in so it understands, okay, I want to go do this. And here's some other cool stuff. All right, there we go. Now, there are other things you can do inside grub that get very deep and off into the dark arts. Like you can set up your own stanza, you can reconfigure stuff to make it, you can put in your own ISO boot. Let's say notice I have found image here, found image, found image. What if I wanted to put my own in here and say boot tinycore off my USB drive that's actually on the motherboard? Well, I could do that, okay? So that's kind of what you have a lot of flexibility with the grub. Okay. All right. Okay. Now, what I want to do is talk some more about some of the things that you technically should have covered in your lessons in test out. Okay. So what I'm going to do here is I'm going to clear my screen, do an ls and see what I got here. I don't have one. Good. All right. I'm going to make a new directory. So I do cd, which puts me at home, right? And I'm going to say make directory in class and do ls. And you can see my new directory in here. But if I want to see the latest thing, I type in ls minus l I like hidden files, all files, no, inode, all files, reverse sort order, and give me SF. Okay, so, whoops, where's my R? I don't think I need all of this. How about liar? That works. In classes up here, user. T, show me the time in reverse order. There we go. So there you can see my file that I most recently touched. That's very, very handy. And if you want to see the hidden files, you can use A. And if you like the fancy little thing at the end of it, like the, is it executable or a directory, you can put the big F. And S shows you symbolic links, if there's symbolic links or not. Okay, I don't have any. I do need to show you symbolic links. That's symbolic links to me are absolutely awesome in the world of Linux. And when I started getting deep into the world of Windows Server, I went, oh, are you kidding me? This sucks. They have something that approximates a symbolic link, but it is not the same. Okay, it is truly not the same. What you'll find is that a lot of folks in the world of cloud and even, do you really think Amazon runs Azure on Windows Server? No, it doesn't scale. Okay. And now if you're a purist, you're going to say Linux doesn't scale. And I would not argue with you. You know how they get it to scale is they put it on a mainframe and put several versions of Linux or several slices of Linux on different LPARs and manage each different logical partition for each Linux instance. There was a company in Sweden that removed their entire computer room and replaced it with 2 mainframes. And they were one of the biggest internet service providers in Sweden at the time. And they basically consolidated their footprint. It works. It's great. You can even download the version for Alpine Linux to run on the IBM ZOS, which is what they put on the mainframe. Good luck getting access to a mainframe. You can find used ones, but unless you really know mainframes, I wouldn't recommend it. Okay, because you have to pay IBM $80,000 a year for the privilege of running the ZOS operating system. Okay, but businesses don't mind paying those fees because they want to be able to sue somebody when things go down. Okay, all right. All right. Okay. iOS is AS400. ZOS is OS 390. Okay. All right. Now, let's talk about our path statement. Path, I'm going to do echo $path here. This exercise that I'm doing, follow along. If you've got a Linux box loaded, if you don't, how come? You should. Okay. I want you to look at my path statement. Okay. Pretty straightforward. I'm going to change directory to in class. I'm going to write a very simple shell script. vi hi. And I put in my shebang line bin bash. Notice first line, you need the shebang, as they call it. I like to put in the name of the file here because of my years of pain and anguish. Okay. And then you can actually put in comments if you want, like dates, time, who wrote it, so you can go back and yell at them. But in my case, I want to do that. I'm simply going to say read name and say echo. And I'll do this in what is your name? Question mark, space, double quote, and change lines. Put this down here. And then I'll say echo. Hello, comma, quote, space, dollar, name. And then I will put another echo at the end here, just to show you that you'll see a lot of init scripts like this. It says done. And if you want to echo a blank line, you just put in that. You can get away with this depending, but when you start jumping between shells, I don't recommend it. Okay. And then at the end of the file, you can put something in there. Sometimes your style guide that you're working with will tell you to do this. Okay. Okay. Now, all right, here we go. So now here it is. So I can type in bash, say hi. Where's my name? Ta-da! There it is. Notice the second line. Let's go back and edit this and put a line, a couple blank lines after done. Okay. Just for fun. Run it again. My name. There it is. Okay. So it's spaced out. Says hello. No arguments. Now, what do I need to do to make this run? Everybody knows this one, right? Trick question. Not really. chmod. I have to make it executable. Okay. This will come up in a test. Not just mine, but an interview question. Okay. Well, there it goes. It works. Now, let's look at my bash RC for a second here. And I want you to look at my path statement. I want you to notice that little dot. This is something that can get you into very, very serious trouble. It is not considered best practice. Let me explain. Okay. So let me source it by doing dot bash RC. And then echo my path again. Oh, it's still there. Probably have to log out again. Just make sure it's. Now let's see here. Yep, it's gone. Now I want you to, I learned something. You know, you're always learning in this crazy world, right? So I'm going to show you history. Here's a piece of trivia for free. Notice the last command is history. If I type in history again and show my history, notice it's not showing up. How about this one? Let's do ls minus ltr. Okay. I'm going to do the same thing, except I'm going to put a space in front of it. If I look at my history, you don't see it twice, do you? You only see it once. If you prepend your command with a space, it will not go into your bash history. I'm sure that's documented somewhere. I discovered it by accident just recently. And I'm going, really? Well, that's clever. So I can hit space, password, change the password, and nobody will know I have changed password in the dot history. And your dot history is put in this file called .bash _ history. Now, long story, not really long story. Having your history laying around is handy. You don't necessarily need to make it available to everybody on the planet. But what it does help you is when you have to go in for review and say, what did you do last week? Well, you can run your history commands. You can kind of see, remember, it kind of might jog your memory to remember what you did. The other thing is you can follow up on coworkers. When I was working at Foster's, this guy would say, hey, I fixed the problem. And he would never tell anybody what he did to fix things. And it was almost always a problem with a record lock, or I would say in his case, 80% of his fixes were the printers didn't work from the spooler for some reason. And I said, and I asked him, and I said, let's have a meeting, let's talk about it. He kept putting me off. He never did tell me how he fixed things. So what did I do? I went into the AIX history and I harvested all those shell history scripts and I put it all together, and I realized, no, this guy wants to be important. He wants to fix these problems so he looks like he's important. And I go, well, I don't want to be that way. I would rather have nobody in the company know my name, because if they know my name, something's broken. So what I ended up did is I created a really simple web page that basically ran that script via CGI and bump start the printers. And it solves so many problems because people would, they can't load the trucks and so on and so forth. And he never asked how I did it. So, he didn't last too long after that. So word got out, I guess. So our past statement, history. Now, if I change my directory to in class here and type in hi, it doesn't work. There it is. It's executable. Why doesn't it work? I mentioned this in passing last class, I think. It is not in my path. So what do I have to do? Well, I can change it temporarily. So let's change it temporarily. Let's say export path. Don't use a dollar. And put in $path colon, and then I will give it the fully qualified path name so it makes sense to you. Okay. So I'm exporting it. What this means is that it's now going to be in my working environment for this. Whoops, one too many. I forgot when you see that, hit Control C and fix your quotes. Okay. Now if I type in bash and do echo $path, you see in class is in there. And if I can type in bash, every time I type in bash, I get a new chunk of memory. But because I exported that, it brings with me my path statement. So I can now type in hi from anywhere that's going to work. Okay, doesn't matter where I am in my directory structure, because Linux defaults to the search path first, and it will not run from your current working directory ever unless you change your path to have, this funny little thing at the end. Okay, you need that little dot I was telling you about. That is, they highly recommend not using that, because you can be in the wrong directory and type in RM and you end up doing something dangerous. Okay, the putting your current working directory into your search path is not considered best practice. Okay, you can get yourself into trouble when you're doing serious admin on production boxes. Okay, now in my case, none of my boxes are in production, so I use the dot in my search path because I'm lazy. Okay, gives me, so I don't have to type out the fully filed path name to run a script I just wrote. Okay, it just works. Okay, all right, there's the path, and now let's show you this one. Can you see a pattern? Whoops. Echo. Notice how it's decrementing 5, 4, 3. Well, what this is telling me is how many levels of bash I'm down. Okay. So if I type in exit, how many do I have? 2. Exit. How many do I have? 1. So shell level tells you how deeply nested you are in your shell scripts, because trust me, you need to know this. When a shell script calls a shell script, calls a shell script, calls a shell script, you kind of need to know where you are. This is the same thing with C and C++, where you do your include, and then your includes include includes, and your includes to your includes include includes. And debugging that sort of thing is kind of a pain. But what you have to do is use your debugger. Your debugger makes a big difference on how you can follow the chain reaction of what's going on. Okay. All right. Okay. Shell scripting. All right. The other things I want to show you while we still have a few minutes here is that I'm going to show you the difference between symbolic links and hard links. I flew through this last time, I think. And so what I'm going to do is do an ls minus l. I have one file. So I'm going to say ls minus, I'll use a hard link, say hi to hello. Except I need the right command. So what happened? Now notice when I did LL, it's an alias. Let's see what my alias is for LL. If I could spell alias right. That's my alias for LL. It's giving me, tell me if it's executable, what kind of file it is, long listing, inode, symbolic links, and hidden or not. Okay. All right. Now, notice when I did LL, these two numbers are the same. What are those numbers? That's the I in ls minus I. It's your inode. Think of this as a pointer to where you are on disk. Okay. So if I say ls minus I, it shows you all the inodes I have in this directory. Okay. Notice that they are the same. So if I cat hello and cat hi, there's no difference. They are the same. I can run diff command hi hello. Nothing. There's no difference between the two. If I edit one of them, let's remove a couple of things and then put one right here. Echo. And I run hi. There it is. Run hello. Notice it's still exactly the same. You saw me edit hi. And if I look at hello, you can see it took my changes. What happens if I remove hi? Still works. What did we do when we did the ln command? Okay. ln is link, and there's two types of links. The link is going to be either hard or symbolic. What we just created is a hard link. Okay. This hard link means my two files are identical, the same. The only difference is the name. Okay. So what I'm going to do now is show you when you take the file here, the hard linked file that I basically copied with the same inode, and I'm going to use a symbolic link. Okay. That's where you use the ln-s for symbolic. What I want it, and then I'm going to go back to hi. Notice when you say ls-s, it shows you the color, its size. That's the size. Okay. And if I do the ll, which is my alias, you can see that its hi is pointing to hello. It's a different color. Notice its size. It's small. Notice the inode. It's different. But when I run hi, I missed my home row. It's the same. It works the same. But now if I remove hello, let's do this. Let's do another hard link to hello to hi to, so we can look at what's going on here. So we see that hi to and hello are the same. Hi is pointing to hello. If I remove hello, notice it gives me a different color. Still points to the same inode. But when I try to run it, because all I have is a name, that's it. I don't have anything else in other than a name. So it's a broken symbolic link. Okay. So I can safely remove hi and not have any worries. Okay. So if I create another symbolic link and say hi to back to hello, hello will work as long as a hi to stays in existence. Okay. So symbolic links and hard links are a thing in the world of Linux, and where they really come in handy is if you've ever used Dropbox or OneDrive or Google Drive and you got it set up on your Linux subsystem, you can back up a file by just simply creating a symlink to it, and it gets backed up into Dropbox, which is really kind of slick. Then you don't have to worry about, is it in the right directory or not? You just symlink it, you can forget about it. Okay, works. Okay, so that's symlinks. Okay, now you have a question here. Echo shell level says everything is just fine. You are in Christini. Good luck. You are actually inside of a container inside of a container. So try typing in bash, 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 and see if it still says the same thing. And if it does, well, sorry, don't know what to say. Either it's because you're in a highly virtualized arena. The Debian subsystem that's in Christini is extremely highly modified to work with Chrome OS. It is not Joe generic Debian. You can't just load Debian into Christini and expect it to work. They've recompiled everything to be specifically for the Christini thing, okay? But it's enough to get you poking around, okay? Write scripts, add things to your search path, and so forth, okay? All right, so that's kind of what I wanted to cover. And then, oh, I think I mentioned this last week, is Z Shell is on Mac. If you boot live Kali Linux, Z Shell is the default shell for Kali Live Linux. You basically program it the same as you do in Bash, but it does have some extended features. But more of those extended features are not in the programming language per se. They are in the user mode, like it has spell check built in, and it's got a bunch of things built in for the command line to make your command line a lot easier to navigate, I guess. Okay, especially if you're not a command line person. Okay, it kind of does some educated guesses on defaults for you. Okay, I don't have any problem with it. It's the thing that is, why do I don't want to have to install Z shell on everything I touch. Okay, Bash works fine for what I needed to do. Okay, all right, and then there's an editor I want to show you. That's how many characters it is. That's the last line. That's the first line. That's the third line. That's the fourth line. What if I want to change something on the fourth line? That's the line I'm on. I have to say what to where. And I think I have to do S and then print. How would you like to edit all your code that way? Yeah, that's the way it used to be. Line editors. If you remember DOS Edlin from 2.1 and 1.0, and well, Edlin survived all the way up to DOS 5. No fun, because you had to visualize the entire code base in your head or have a printout. Okay, not fun. But this much I can tell you. Ed, good old Ed, is on basically everything. So if you know how to use Ed, you can get by on a machine. Okay, and then you say quit, or what is it? Quit, I think, or is it exit? I always forget. EXIT. Control C. Who cares? I forget. I don't use Ed very often. I'm surprised I remembered that much. Okay, and let's go to in class and see how much I corrupted my file. Not too bad. It didn't save my where though, did it? So something about the S didn't work. Okay. All right. Okay. Yeah. The golden era, I would not call it the golden era. The good old days weren't that good. I know better. Okay. All right. Now, any questions and complaints? Things that are really fuzzy. in your thinking, or you just don't get, let me know, and I can work with you one-on-one, or we can do Zoom. We can do, Slack me. If you're on Slack, you see my little green dot. I'm usually in front of the computer somewhere. Okay. Okay, Ubuntu told me to reboot in safe mode, and I have the boot menu and put in the flag. That's grub, or that's grub. That's not Ubuntu. What that means is there's a corruption somewhere and it can't load the kernel. And they want you to load into safe mode if you're on a dual boot machine and that message is coming from Windows, Windows is telling you, you screwed up my boot editor. Go fix it. That's if it's coming from Windows, it's telling you to fix the equivalent of grub and that. What is that? The boot edit. It's a hidden file. You have to go in and edit and tweak on it. I don't know. But if you can get Ubuntu to load, do the update grub and see if Ubuntu will reboot again and clean up. If it doesn't, then it's probably a Windows problem on a dual boot machine. Okay, I could be wrong. If you get the shell prompt, what shell prompt are you getting? Is it a shell prompt that looks like this? Just a bracket? If you're getting that, that's a grub prompt, and you have to know grub. Okay, this is why I'm asking you to build up a USB. If you get the $, that means, or the £, that means you're in single user mode and you can manipulate your machine to fix it. Okay. Why don't you learn to walk before you run on that question? Okay. Because grub is the interface between BIOS, the disk, and which kernel you're going to boot. So grub boots before the kernel. Once grub is done, then the kernel that you chose is what boots into RAM, and you get your operating system. You can also use grub to boot Windows. Don't ask me to set it up, okay? I never use always when it comes to technology. I would venture to say it's probably grub. There's flags when you boot grub, and they're the defaults. That's why it's in this directory. Etsy default. That's why it's called default grub. They're asking you to put in a flag somewhere in here to make things work. Okay. What? I don't know. Okay. This is where I would boot Kali Linux and go in there and see if I could use Kali Linux and one of the recovery tools in forensics to see if it could rebuild the grub loader for me and make sure it would repair. Because Kali Linux also plays well with Windows. You can use it to, if you boot a Windows box with Kali Linux, you can go in and find the passwords and actually remove the passwords. You can't change them, but you can remove the passwords and then reboot the Windows box. And then that user for that Windows box now has no password. So you can do forensics on the computer after it's booted, okay? But you usually take a hard copy of the drive before you do that. Use DD or some other tool, basically copies it so you can actually go play with it in a sandbox, especially if it's court legal, okay? All right. On that note, other questions? SAM files? Yeah, they're SAM files. Okay. Now, Charlie, why are you the only one in chat? Is it because you take up so much time and nobody else wants to put anything? Okay. if I was told to boot and none weren't. Boot in none work. Boot network. Oh, boot with no network. Yeah, no network takes you into single user mode. Yeah, you can look that up. Grub single user mode. That's the easiest way to do that. Fair enough. Okay. No, it's not just Ubuntu, it's Grub. Okay. So somebody says, somebody's defending you. That's good. All right. Okay. All right. I don't mind. It lightens my day. You know, it's hard to sit here, big open lab with nobody in it, you know. Sometimes it's hard to stay focused. All right. We're getting close to the end here. Okay. Covered the grub. Yeah, symbolic length, hard length, add length. Okay. And then next time I'll go down and test out and look at some of the stuff you've covered, and then explain a few things that you'll see in industry that are not necessarily in test out. Okay, that's kind of where I, you know, the test out is phenomenal for you to get a good base understanding of Linux until something breaks, and then it's really hard to figure out. Okay, and I can kind of help with some of that stuff. All right. Okay. On that note, learn Red Hat. That's great. Then I would recommend, don't use Christini, run Red Hat, because the printing subsystem in Red Hat is very different than what it does in other distros. The way they've modified cups. Cups is the printing subsystem that is provided to you open source from our good friends at Apple. So Apple and HP have a really good relationship. So every time you load a new driver, they know who and where that new driver is going. Okay. So if you want to bypass all that, there's other ways to print. Okay. But the printing subsystem is beginning to standardize on cups, but cups, like many things, is getting fatter and fatter and fatter and fatter. Okay, it's great. You turn it on, it finds your printer and it automatically connects. It's ready to go. Well, if you don't want all that overhead, every time you boot your machine, you can strip it way back. Okay. All right. CentOS be the same. Big argument discussion there. Yes, no, maybe. Red Hat basically encumbered CentOS, so it's no longer free. And the guys that wanted to keep CentOS free spun out and created a new company called Rocky Linux. And Rocky Linux is doing the same business model of trying to stay in line with the Red Hat Enterprise version, what they call Red Hat Enterprise Linux, RHEL. Okay. Okay. So I won't say use Rocky Linux. You need to find out what your employer uses. If they're using CentOS, use Cent. Okay. If they're using Red Hat and they're using Red Hat production, if you're a student, you've got a student email, talk to Red Hat. They'll give it to you for free for a little while, not forever. Okay. Okay. But CentOS, I would say, is probably the closest thing that you're going to get to the Red Hat production Linux as of today, because I'm going to bet the employer doesn't have the latest and greatest Red Hat release. So try to find out what release it is and try to match it up with the right version of CentOS, so you're not rereading the wheel. Okay. Well, then If they don't say, just use CentOS or Fedora for that matter. Use the open source version. The difference there is you don't get ButterFS, you don't get some of the rollback and commits in the journaling file system. But for user mode, as somebody moving into that position, that's the tools they're going to teach you anyway. So if you get a really good handle on Fedora, you'll be able to do fine with the thing. If you were hiring me for Red, what would I ask for? I would ask you if you knew my product line. Do you know Red Hat? Do you know Fedora? Do you know Silverblue? Do you know all these things you're doing? Do you know that Red Hat's now owned by IBM, and where's it going? What's the product mix? Where's it headed? That's what I would do. You know, ask your employer or the future employer. If they say they're on Amazon, well, then go get an Amazon instance and spin up Red Hat with their flavor and see what it's like. Okay. Okay. Well, you can do there's a free tier with Amazon called the Micro. It's free for 1 year. Okay. But you have to be very careful. Don't leave it running or it'll come back to bite you. Okay. All right. All right. On that note, I'm kind of done for the day. So if you have questions, feel free to Slack me. I have office hours today, but I also have another meeting I have to go to. So I'll be sitting at my desk, listening to the meeting, answering questions via Slack. Okay. Probably won't be able to talk to you during the meeting, but I can sit there and do the Slack thing. Okay, folks, on that note, we will stop the share and stop the recording. When it gets posted, when it's finished, I will let you see it. Stop recording.